Alright, we are looking at equilateral and isosceles triangle. This is lesson 5.04, exit ticket. So, equilateral triangles. For an equilateral triangle, that is a triangle with three congruent sides. An equilateral triangle also is an isosceles triangle because it has at least two congruent sides. So to be isosceles, you have to have at least two. It has three, so it does have at least two. And also, equilateral triangles are equiangular. Equiangular means three equal angles, right? So lateral being side, right? Angular being angle. It has equal sides and angles. Why are they 60? Well, remember our triangle angle sum theorem. If you have all three angles and they're all the same, then the sum of all three angles being all the same, the sum of all three angles has to equal 180. Well, then if I use a variable x like I'm doing there, and I divide by 3, I can prove that the three angles have to be 60 degrees in this case. That's why they're always going to be 60 degrees, and why earlier in a video previously I mentioned that you can never have a equilateral right triangle. It's not possible to do that whatsoever. Okay. Now we have the isosceles triangles. Now an isosceles triangle is a triangle with at least two congruent sides. Okay, and the reason we're saying at least two congruent sides is you can classify an equilateral as an isosceles as well, but it does have a minimum of two congruent sides. And those sides are often referred to as the legs for good reason. If you look at the upright triangle above there, you can see of the isosceles. The two angles opposite are called the base angles. So these right here are the base angles. Base angles are defined there, and that diagram is nicely labeled because it shows everything, including the vertex angle as well. And then, of course, what's really nice about the included side is the base of the isosceles triangle. The base is the included side. The angle opposite the base is the vertex angle, right? So they're talking about what's opposite the vertex angle there, right? So just be aware that we have that going on. So vertex angle is opposite the base. Alrighty, so now we have the scalene triangle. These are kind of neglected, honestly, because they're just triangles that have no congruent sides. They're not equilateral, they're not isosceles, they're all different sides, and that's the fact that we leave you with. So let's go ahead and work with an isosceles triangle first. We want to determine what sides are the legs. So here we can see that we have VW clearly labeled, and we have VU. So those are going to be the legs of the isosceles triangle. We want to know what the name, what is the name for angle U and angle W. The name of them with respect to them being a part of the isosceles triangle is that those are referred to as the base angles, right? We call those the base angles, right? Because the base is the side that's opposite the vertex angle. That would be WU. Another way to think of it is it's the included side, right? So this side highlighted in green is included because it lies between the base angles. And then WU also happens to be opposite the vertex, right? And that's what V is, right? This is the vertex angle of the isosceles. So we're kind of showing you what it would look like if it was kind of knocked on its side. It still maintains that the thing highlighted in orange, the angle highlighted in orange is the vertex angle, and then you have your base angles at W and U, and WU is the segment that's the base. And then of course you have the legs of the isosceles triangle. So I would pause the video and see if you can identify the sides that are the legs and the base angles of that isosceles. Okay, so you should have selected RP and PQ for the sides for the legs, and R and Q for the base angles. How about this one? Pause and see if you can come up with the base of the isosceles and then the vertex angle. So you should have selected QR for the base right here, and the vertex angle, of course, is angle P, the angle opposite the base. So looking at a description of the types of triangles that we're dealing with, right? On one hand, we have triangles that are defined by their sides, we use the words like equilateral, isosceles, scalene. And then on the other hand, we have triangles being defined or described based off their angles. Right triangle, acute triangle. We call it an oblique triangle. However, it is often commonly referred to as an obtuse triangle as well as an oblique, okay? So oblique is just a kind of a fancier word, but obtuse means the same thing. Most math textbooks are not going to use the word oblique. They're going to use the word obtuse. That's why I'm referencing that just as an example, okay? So we have different ways to classify it, right? You could describe, for example, you could have an equilateral triangle that you can then define as acute, right? Because all the angles are 60 degrees, so it's an acute equilateral triangle, literally. It's in the name. It's really defined that way. A scalene triangle can also be an obtuse triangle. So just as an example here, we want to look at determining the measures of the angle of this particular triangle. And the thing that is really important here is the relationship between the base angles. So we want to start off by identifying first what angles are actually congruent, right? So because this is an isosceles triangle, and we know that because the sides are the same, the base angles we have are here and here. Those angles are going to be congruent to each other. So angle R is congruent to angle P. And the reason for that is because it's an isosceles triangle. Now, you might see this little symbol here, by the way. You might have seen me in my other videos make this. That actually is me being a little lazy. It literally means because. So if you see me use that, it's a mathematical symbol that means because. I like to use symbols to shorten what I'm saying. If I flip it around, for example, it does mean therefore or thus. So if you see me say that or write that, that's what that indicates. I just want to clarify. I like to abbreviate when and where I can. So here, angle R and P are going to be congruent to each other. Now, because of that, that means that if this angle is 3x, then so too is that angle. And based off the triangle angle sum theorem, we know that the sum of all the angles in a triangle is 180. So we can add all three of these up and set that equal to 180 degrees. There we get 15x, and we're going to end up dividing by 15 afterwards there. So we end up getting a value of 12 for our variable x. So we know what x is actually going to equal. And they're asking for the measure of the angles. So the first step was to find x. The second step is to find the angle measures, right? So the measure of angle R is going to equal 3 times the 12, or 36 degrees. That happens to be the same as the measure of angle P because it equals the measure of angle R. And then the measure of angle Q is 9 times 12, or 108 degrees. So now we have all the angle values of the isosceles after finding the value of x. So maybe pause the video and see if you can come up with the value of just the value of x, which happens to be one of the angles, angle D. So you should have selected 36 degrees as your answer. So in this case, we want to identify that this right here and this right here, those are the base angles, right? So we know that angle E and angle F are the base angles. They're congruent, right? So we know that angle E is congruent to angle F since it's an isosceles triangle, right? So that's how we know that, and then we can justify by saying, okay, that means this is 2x as well because they're the same. You have 2x plus x equal to 180, so that equals 5x equal to 180. Divide by 5, and you end up with 36 degrees. That's actually the measure of angle D. So in this last example here, we are going to find the measure of angle C, which is the vertex angle. We are told that this is, of course, isosceles because the side lengths are marked as congruent. So we see that it is isosceles. We want to make sure that we recognize that it's isosceles, okay? If we don't recognize that, then we can't use any of its properties, right? So that implies that angle A is congruent to angle B because those are the base angles. A is marked here, B is marked here, those two expressions. So in step number 1, we're going to find the value of x. So to do that, we know that we have 4x plus 7 is going to equal 5x minus 3. And then we can go ahead and do some of our operations, subtracting the 4x as an example there. So here we've got 7 is equal to x minus the 3. Here we're going to go ahead add the 3 to the 7. So we end up with x is equal to 10. So I know that x is equal to 10 here. So then I can go ahead to the second step. The second step is going to be to find the measure of C. Before we do that, we can find the measure of A by plugging in our expression for x, our value for x. So we're plugging 10 into that, and we're evaluating. And of course, that's going to get us 47 degrees. When we simplify, 40 times, or 4 times 10 is 40 plus 7 is 47. The measure of angle B, well, we don't need to plug anything in. We know it's 47, right? Because it equals the measure of angle A. So if we want to find the measure of angle C, that's the third angle that's missing and the only angle now that's missing, right? So the measure of angle C, therefore the measure of angle C, is equal to 180 minus 40, not 47 rather, but 2 times 47. Why 2 times 47? Well, if I erase these, I know that both of these are 47 degrees, right? So I have to make sure to subtract both of them. That's certainly one way that I could write it. So I really have 180 minus 94. That's going to equal 86 degrees for my measure of my angle. And now I have all 3 angles, including the vertex angle there at the top. And that's exactly what I want. So that's going to be our exit ticket here for today. We are looking for the measure of angle C. We just did an example of that, okay? And in our case, our problem was this problem right here. So just referencing that example of that slide, I would refer to that. If we say that a triangle is equiangular, remember that that means all the angles are the same. So just remember that if you do have a triangle where all the angles are the same, right, then that tells me that they're all 60 degrees. And that should also tell you that the sides are the same because it's equilateral, right? So use that information to help you figure out an equation to solve for AC. Also, as a tip, make sure that you're recognizing that it's the length AC that you are looking for, not just X. The last example there in triangle ABC, we have the measure of angle A, which is this angle here, and you kind of have almost like a domino effect going on here. You have to find the measure, however, what are the measures of angle, I should say what is the measure of angle ACD in the figure, right? So we're looking for this angle right here. And you should be able to very quickly identify that based off of what is provided to you in the diagram and your knowledge of isosceles triangles. And that is going to represent your 5.04 lesson on equilateral triangles and isosceles triangles.